Hello everyone, my name is Greg, and today I would like to walk you through 5 questions from the latest instrumentation exams seen in the last 30 days across all authorities. Topic for today is Flight Management System and Flight Management and Guidance System. So, question number 1. In flight, which navigation receivers are typically used for flight management position updating? DME, VOR, localizer, and LoRa receivers? DME, VOR, localizer, and INS receivers? DME, NDB, and GPS receivers? DME, VOR, localizer, and GPS receivers. Alright, so the flight management computer continuously calculates the most actual position using GNSS position, radio position, and IRS position. And from these sources derives so-called FMC position. For the radio position, the FMC has an ability to auto-tune the best possible navigation aids to calculate the most accurate position. It can tune up to 6 facilities, and they might be different than the ones we select manually. All of these nav aids must be in the database, and they have to be within altitude and distance coverage. Acceptable facilities for radio position fixing are DME, VOR, and localizer. Now, the FMC prioritize the sources depending on their quality. The typical order of position updating is GNSS, DME, VOR DME, and as a last resort, the IRS updating. Of course, even though a system uses GNSS, it still monitors radio position and IRS for cross-checking the consistency. Going back to the question, we can see that answers number 1 and 3 are incorrect, since they include LoRa and NDB, so nav aids that are not used for FMC position fixing. Now, let's check answer number 2, DME, VOR, localizer, and INS receivers. Every item here can be used by FMC to generate FMC position. However, this question refers to receivers only, and INS is not a receiver but a standalone system. Therefore, this one is also incorrect. Remember to always read questions very, very carefully. So now we are left with answer number 4, which is perfectly correct. DME, VOR, localizer, and GPS receivers can be used for FMC position updating. And answer number 4 is correct. Question number 2. On the CDU of an FMS, the message insufficient fuel is displayed if too little fuel is on board for diversion when the flight crew initiates a go-around procedure, the fuel quantity falls to 25% of the total capacity of the fuel tanks, the refueling process on the ground is stopped before the required amount of fuel is on board, or the calculated estimated fuel at the destination airport is less than the fuel reserve value entered. Okay, so both systems, whether it's FMS, the flight management system in Boeing aircraft, or FMGS, flight management and guidance system in Airbus, have capability to calculate the remaining fuel at destination or alternate. These calculations are based on current flight plan entered to the FMGC, as well as on conditions like winds, altitude, temperature, and current fuel flow. Whenever a system detects that predicted value at destination or alternate is lower than the final reserve, you will see an insufficient fuel message on the MCDU scratchpad. Now, it's not an emergency alert. It's an advisory message to prompt the crew to take an action. So, going back to answers, answer number 4 will be correct. The message insufficient fuel is displayed if the calculated estimated fuel at the destination airport is less than the fuel reserve value entered. Now, answer number 1, technically, it's not fully wrong, since any situation where the FMC or FMGC predicts that fuel at alternate will fall below final reserve will trigger the insufficient fuel advisory. However, at least for me, this answer is just too limiting. It's only one scenario and the philosophy behind this advisory. Also, from my experience with EASA exams, whenever you are in doubt and one of the answers is exactly the definition, choose that one. And answer number 4 is correct. Okay, question number 3. During the FMS performance initialization procedure, the pilot notices that the aircraft type stored in the aircraft performance database is not correct. This issue shall be resolved before flying because incorrect FMS outputs may result regarding fuel management, optimum altitudes and vertical flight profile, wind direction and speed, outside and air temperature and freezing level, waypoints, airways and lateral flight profile, automatic tuning of navigational aids, and position updates. Okay, so FMC databases, we can divide it into 2 types, navigation database and performance database. The navigation database is updated every 28 days according to IRAC cycle. It contains all details regarding airfields, navigates, procedures like SID stars and approaches, as well as ATS routes or airspace requirements. Performance database, on the other hand, contains information regarding aircraft model and engine rating. Pilots cannot make any inputs there. However, it's crucial to check if the model and engine data corresponds with the aircraft that we are going to fly. Now, based on data contained in performance database, FMC computes, among others, optimum cruise levels, fuel predictions, engine thrust data, or for example, the most efficient flight profiles. So we can see that the answer number 1 will be correct. Fuel management, optimum altitudes, and vertical flight profile. Just to cross-check other answers, we'll see that answers number 3 and 4 contains items regarding the navigation and database. And the answer number 2 doesn't have anything to do with any of FMC and databases. Yes, so answer number 1 is correct. And we are moving to question number 4. What function does a CDU MCDU serve? To extract information stored in or processed by the FMS and load new or updated information into the FMS, to engage the alignment procedure for the INS IRS and to switch between nav mode and attitude mode, to engage or disengage the aircraft APU and monitor its status, or to engage or disengage the autopilot, set different modes, and choose between out modes and engaged modes. Okay, so CDU and MCDU, so control display unit and multi-purpose control and display unit for Boeing and Airbus respectively, are the pilot's interface to interact with FMC or FMGC. It consists of a screen and a keyboard. Through CDU, we can input data into the FMC such as flight plan or for performance data like zero fuel weight, block fuel, or V-speeds. We have also an access to navigation database, and in case of MCDU, the multi-purpose part refers to, for example, communication functions like ACAS, messages, reports, or ATS data, or CPDLC, so control pilot data link communication. So the correct answer for this question will be answer number 1. Function of CDU MCDU is to extract information stored in or processed by the FMS and to load new or updated information into the FMS. Going through other answers using Airbus A320 as an example, we can switch between nav and attitude modes on the ADIUS box on the overhead panel. We are not doing that through the MCDU, but we can check the navigation accuracy there. We can engage and disengage APU on the overhead panel, and we can monitor its status on the ECAM status display. And for selecting different modes and engaging the autopilot, we use FCU, so Flight Control Unit, which is situated directly in front of both pilots. Alright, answer number 1 is correct. And the last, fifth question. Why can't you find the user waypoint you entered 2 months ago? The navigation database was updated and the waypoint was deleted during the process. Waypoints are deleted after every single flight, so it was deleted. Because out of storage, the system deleted the oldest waypoint that you entered to make a place for the new one. At some point after the waypoint was entered, the battery of the aircraft was disconnected and this reset the navigation database. Here we are being asked about the navigation database. Even though a pilot cannot overwrite or change an existing data, we can add some user waypoints. Now, the navigation database is updated every 28 days according to IRAC cycle to ensure that the data in the FMC is correct. During this update, all waypoints created by the crews are erased. It is a feature that ensures that no user waypoint will be defined by an invalid or outdated data. Just imagine a situation where Navigate was disabled and does not exist anymore and try to fly to a waypoint which has been defined by it. So, going through the answers, answer number 1, the navigation database was updated and the waypoint was deleted during the process will be correct. And so is correct. All right, and that's all for today. Thank you for being here and hopefully see you next time.